Okay, we move to Model Builder, automate the analysis. So suppose unexpected changes occurred after we finish the analysis. Maybe an update table of vacant parcels become available. Maybe after seeing the results, the city council wants to add or remove criteria or see how a change in threshold values affects the outcome. So of course we could redo the analysis, but even a small change, especially if it comes at the beginning of the process, could make a lot of tedious work. So this is the moment to introduce Model Builder. So the Model Builder can encapsulate the entire workflow in a model, a custom geoprocessing tool that runs with the push of a button. So a model looks like a flow chart or schematic diagram that shows the steps for manufacturing a product. Inputs, outputs, and processes are represented by geometrical shapes. Arrows connect the shapes to show the sequence of operations. For an example, so understanding a model that we will have to show. So a model is more than a visual aid, that also an engine. The data sets and tools it represents are embedded in the model schematic elements, so that running a model sets in motion a train of geoprocessing operations. So here the model will basically repeat the analysis tasks we did. So there are lots of good reasons to build a model from the analysis. So first, since it is a diagram, model takes the whole workflow transparent and open to scrutiny. So this visualization may reveal the analysis weaknesses or confirm its validity. Either way, it brings the methodology into the open. Second, a model stores and thereby documents the workflow, sparing us the task of keeping detailed notes on what we did and why we did it. And third, models are flexible, so they easily accommodate the kinds of changes to inputs or parameters mentioned above with little effort on the part. And fourth, models can be shared with colleagues, saving development work and encouraging collaboration on sound methods and best practices. And fifth, models run quickly, just wait and see. So we're going to set up the model. We're going to create an output geodatabase and set the workplace. So which we did previously, now we have to set one just for model, and that will be very neat. Okay, so we already created one, and now we will keep the results in a separate geodatabase simply to avoid confusion between the outputs that were created from the analysis output geodatabase. So in geodatabase, I'm going to right click on it and new file geodatabase. So new file geodatabase, I will say model outputs, and then I'm gonna click save. So next, model output, and on the analysis tab, so analysis tab, and then I have tools. Yep. And then I don't need the tools. I have to set an environment first. So we're going to change the environments model output and model output. So we can see the coordinate system will remain the same because we still work in the same area. So here you don't see they have any, but I'm gonna just click OK. As a reminder, the environment settings set the default output location for geoprocessing tools. We can always change the output location for any individual tool, but setting these default workspaces is convenient when trying to keep the outputs in the same geodatabase. So that's the beauty of ArcGIS Pro. And now we're going to create a model in the project toolbox. So a toolbox is a container of tools. So of course, we already see many times that it put into category and it just like layer within layer. So a model is a type of tools, just like buffer, identity, and the other tools we have worked with, and as such must go in toolbox. However, it it cannot go in a system toolbox like the analysis toolbox we worked with previously. An ArcGIS Pro project automatically contains a project toolbox. So when we create ArcGIS Pro project in already, and then the project toolbox was created for us already. And then we will find a toolbox with the same name as the project, and we will expand the toolbox and notice that it is empty. So we're going to right click on the toolbox, so and go to new, and for new then I will say new model, and we put a model within the toolbox. So an empty model flow window opens, usually replacing the map view. Yes, it is, and it's a I usually do not like the whole screen view. Usually I just like to make a flow, resize it, and put it here. So the default when you sometimes you open something and just take the full screen for ArcGIS Pro, which I hope sometimes it'll allow me to float it. I don't know. Maybe hopefully later I will find out. So if it doesn't open to replace the map view, we will drag the model tab to the center of the map and dock it. We can always return to the map by clicking the map tab at the top of the pane. So, and then you can see Model Builder on top of the ribbon. And also note that a new tool named Model is in the toolbox, which is right here. And it has a model icon next to it, signifying that the type of tool is a model. Models are a special kind of tool, but we will see that once completed, they can behave like any other tool in the toolbox. So now, understanding the model, we will put things inside of it. So let's see some model. Let me see if we can find something in Esri. So model builder. There. So model builder. This is the model builder, and to get a basic idea, forget about the Los Angeles River for a moment and prepare a Saturday morning breakfast. So you need an ingredient and put things together like a cookbook. So on the workflow, like a recipe, and for making a dozen of American pancakes from the scratch, we will pick up the ingredients at the local store and make a batch of celebrate when we have completed this workbook. Then the ingredients are symbolized by the ellipses inputs. So these are prepared in various ways as shown. So the results are the green ellipses. Outputs, we stir the basic ingredients to make the flour mix before adding the whipped egg, oil, and buttermilk. I didn't wait to put buttermilk in it. And the mix should be properly blended before liquids are added. Otherwise, we may get clumps or baking powder in the dough, which will lead to very flat pancakes. After we make the dough, refrigerate it for several hours, or even better, overnight, to allow time for chemical reaction. Then fry the dough in a pan with the favorite flat and eat it with a good brand of maple syrup. Delicious. And can anything go wrong? So if we follow the arrows on a tried and true path, we start improving. We might make the recipe even better, but we might also get the weekend off to an indigestible start. So it is much the same with an ArcGIS workflow. With a complex analysis, it usually takes trial and error to get the recipe right. Typically, we will experiment with several combinations of data, tools, and sequences before finding the best way to solve the problem. Once we find it, we will want to save it and share it with friends, just like the pancake recipe. We experimented a lot with the data and many ArcGIS tools before writing the cookbook. Or the workbook, having having figured out the workflow we implemented in here, but we also wanted to preserve it, encapsulate it, and make it a formula so that it's just like a tube we put, or like a noodle maker. You put everything, and it's just like the tools and everything here. We will just create. It's just like a button that you click, and then it will generate everything for you. Okay, so model builder, and now we're going to set the empty model displayed on the model builder tab, and then we will check everything. Okay, so now okay, and then we will have to see that we will have to see everything here. Okay. Alright, so with the empty model displayed on the model builder tab, we will click properties button. So I'm gonna go here and property. There. So property button. So model builder. Right here. So property is right here, and then okay. And then we have the model here. In the name here, we have in the name text box. So name text box, I will say park suitability analysis, no space. And then later on we can use space, but I think I will just no space suitable. Okay, label, I think I will just do the same. Park suitability analysis. So I don't have to set password, and the label is like a field alias, a name that is more descriptive or easier to read that will be used while we are in ArcGIS Pro. And verify that the box is checked for store tool with relative path. So the model, its input data and its output data can now be moved without disruptions as long as they remain in the same workplaces, folders, or geodatabases relative to each other. Okay, and then I'm gonna click OK, and then note that the name of the model on the tab above the model canvas has updated. So right here, here it's already updated, but the model in the project pane hasn't. We must save the model to commit. So commit, and then and then here it changes. So now commit any changes made to the model. On the model builder tab, and I click save, and then in the project pane, so which the catalog pane, we can see the model now appears within its new label. And here we will have build the model. So the model will recreate the analysis workflow here. Knowing how much work that lesson entailed should give you insight into why models are such an efficient tool, not only for analysis projects, but for any series of operations that we might want to save, repeat, vary, or use as a basis for further development. So recreating the analysis will let you focus on attention on the modeling process itself, since the data and the geoprocessing tools will be familiar. And the data preparation tasks for previously will not be part of the model. So the big advantage of model is that it is easy to rerun them. So we don't want to incorporate operations such as adding fields, calculating field values, joining tables, and so on, which only need to be done once. So here, the model, about half of the analysis steps, saving the remainder of the next exercise. So the stopping point here is more or less arbitrary. So arbitrary, but building a model incrementally is a good practice. So it is easier to find and fix problems if we do test runs along the way. Now we're going to add data to Model Builder. So we will add all the input data for the model. This is the opposite of what we did here, in which we added layers one at a time as we needed them. So either way is fine. It is a matter of preference. So in the project pane, we will expand the project database, so which is right here. And then press and hold the control key. So for project pane, expand the project database. So which is this one. Yep. And then I'm gonna add block centroid and hit control block groups, and then Los Angeles River, hit shift key, no, not shift, control, and parks, and then vacant puzzle, it should be dissolve one. Okay. Alright. There. Okay. And now with the feature classes selected, we will drag them from the project pane to the model as we drag them to the map. So now I cannot see everything fit to screen and auto layout. Perfect. Although we can probably see only one or two of them without scrolling, each dataset is added as a blue ellipse to the model window. This blue ellipse are input data variables, but we will mostly just call them inputs. And then the elements are not automatically sized to fit, so we will take care of that next. Okay, and then on the Model Builder tab in the View group, so we will click Fit to Window button, so which I already did, Fit to Window, Auto Layout, and we should see all 5 elements centered in the model window and marked with gray selection handles. And then the display of text within ellipse changes as we zoom in or zoom out in the model window, and the places where words divide may change, and so may the number of the lines of text. Don't worry if the text display on the screen is different from here. So, and then we hover over any selected element, then drag the whole group to the left of the model window. So I'm gonna select all of them and I'm gonna drag them to the left. And then click empty space in the model to deselect the elements. Now I can finally add the tool. So the tool that I can just go to toolboxes. I remember there was a toolboxes, so there. So 2 boxes. I still have to click this. I can just dock them there so I can have a catalog and processing switch back and forth. So on the model Model Builder, I'm gonna save it now. And then the tools is here, and I just click this, and the drill processing pane display a list of tools, and then I will just go to toolboxes. Switch to the view of 2 boxes, and tap at the top of the pane and browse to the buffer tool, analysis tool, which is right here, and proximity, which is right here, and go to buffer, and click, I cannot just click buffer, so, close it out. Oh, no. Buffer is right here, and I'm dragging here. So drag the buffer tool from the drill processing pane and drop it on the model. And the tool is added to the model window connected by a small arrow to an output feature class element. The tool and its output are gray because they are not ready to run. So the tool must be connected to input data and its parameters to be filled out. And make sure the buffer tool and output feature class elements are selected, marked with gray selection handles. So, and if they are not, we will use the select tool in the mode group drag to draw a box around these elements to select them. So we will drag the select elements down and place them on the right of the Los Angeles River input data elements. So I'm gonna right here and place the pointer over the blue LA input data element until its hand cursor appears like this. And then I click select, and with the hand cursor display, drag a line so like this, and input feature. So with the hand cursor display, drag a line from Los Angeles River to buffer, and the line won't appear until we start dragging. So we release the mouse to connect the input data element to the tool, and the menu is displayed to choose which type of connection to make, and then I say input feature. And on the menu, we click input feature. The tool is now connected to data, but there are other parameters to enter for the buffer tool, so the tool remains gray. So we will right click the buffer tool and click open. So right click on it and click open, and we can open or double click the tool to open it. So I think okay, and then open there. Okay, so it's the same. The familiar geoprocessing tool opens, but this time it is floating above Model Builder instead of contained in the geoprocessing pane. The input features are set to Los Angeles River as specified by the connection arrow, and the output feature class is directed to the default geodatabase. We will rename this feature class in accordance with the convenience, and we will change the output feature class name to Los Angeles River Buffer, and then linear unit, and the default output path should be set by the workspace environment settings and we made earlier. If not, we will use the browse button to browse to the model output geodatabase. So linear, and we will change it into miles and change this as 0.05 and set the adjacent drop down arrow to miles, which I did. And here we click run after entering all the parameters. So we click OK, so run after entering all the parameters to immediately run the tool. In Model Builder, click OK verifies that the tool is ready to run, but doesn't actually run the tool yet. So the tool and output data elements turn yellow and green, so respectively, which means they are properly connected and the parameters fill out. And then on the Model Builder tab, we will save it, okay? And we will buffer the parks now. So previously we did, after buffering the river, we created quarter-mile buffer around existing parks to designate exclusion zone when considering where to site a new park. So here on the Model Builder tab, we will click the tool button if the pane isn't open already. We will drag another buffer tool, so buffer tool, which is right here. And all the name of the elements, input, outputs, and tools in the model must be unique. So we notice that the tool will be named buffer tool. When we drop onto the model, position the tool on the right of the parks, so parks, which is right here. And last time we set the input feature in the buffer tool by drawing a connector. Now we will do it in another way. So now we will open the buffer tool by double click on it or right click on it and click open, and click the input feature drop down. So I'm just do parks, and then input feature output feature class. So so the drop-down list filled with the input data elements in the model as opposed to the layer in the map that we do not see in the previous here. Every input element always technically, so I'm gonna check again. Oh, no, I'm gonna see it again. So there, model variable. So I just choose from parks here, and every input data element blue oval is technically a variable because we can open it and change the feature class it references. We will keep the default output feature class name as parks buffer. And the same here, I'm going to change it into miles. And distances, I will be 0.025. and select linear drop down arrow miles. I did that first, and click dissolve type. So dissolve type, and I will say that all outputs feature into a single feature. So I did that, and then we don't have the visual reason to dissolve it. The buffer that we had here, but we are not going to look at this tool output, but just use it as an input for the next step. But it doesn't cause problem to duplicate the workflow. And we will compare here, and then both buffer process should now be colored in our model. So we will save the model and we will move on. So I'm gonna save it, and gonna save project. Go to project and save project, and then back in here. So now we will erase the park buffer. So to erase the park buffer now, we use the erase tool to subtract the park buffer from the Los Angeles River buffer to remove them from consideration from the new park location. So if necessary, we open the geoprocessing pane by clicking the tool and button on the Geo Model Builder tab. At the top of the geoprocessing pane, we will type erase. So here I'm gonna type erase. So erase is here, and I don't need it, and I have to drag it here. So now I have the erase tool drag into our model builder and position it next to the Los Angeles River buffer. And remember from the previous videos that we did, the erase tool require two input classes. The input features class feature, the input features feature class, the features from which areas will be erased, and two, the erase features feature class, the areas will be erased, the cookie cutter. And now I'm gonna connect Los Angeles River buffer to erase by drawing a line between them. So I'm gonna draw a line. Okay. Input feature. So, and then the erase feature will be parks buffer. There. So, and I have to fit in window and auto layout. Perfect. So now it looks better. So we did was click input feature when we prompt to define Los Angeles River as this parameter, and we connect the parks buffer to erase by drawing a line between them, and click the erase feature when prompt. So the erase elements will now be colored because erase doesn't require any other parameters. We will go ahead though and rename the output feature class to give it a more descriptive name and stay consistent with what we did before. So we will double click output feature class, the output erase, and change the output name to proximity zone. So double click on this and proximity zone. Proximity zone, and then erase the tool is now ready to go, but we can review all the two parameters just to confirm. So click OK, and I'm gonna double click here. Yeah, we have everything as we did before. So we have the Los Angeles River as a buffer, and note that the tool parameter have been filled in for us by connecting and changing the individual model elements. So we will close the dialog box and by clicking OK. And depending on how we have positioned the elements, our model may be starting to look a little messy. As we add more elements to the model, it will become increasingly clustered and difficult to find things. We will use the auto layout to clean things up. So I already did fit into window and then click the auto layout. Much better, right? So the result layout may look different here, but at least I can see here. So we will save everything now, and we will move on. So now we will assign the block group demographics to the proximity zone. After erasing the park buffer here, we will use the identity tool to overlay the remaining area. So identity tool, I remember it should be here. So I'm just gonna go back favorites. So identity, I'm gonna drag identity tool here. And so we have identity drag in here and double click to open it, and we will figure out to see the parameters. So identity, so the identity tool that we will do input feature, it will be group, block groups, and then identify feature. Okay, block groups, input feature. Oh, input feature, it will be input feature. So do I have to run it? So input feature proximity zone, and identify feature, it will be block groups. Okay, block groups. And then output feature class, I will change it into demographics. Yeah, block groups. Underscore demographics. Okay, and I have everything, all attributes, perfect. And then click OK, and auto layout for sure. And then zoom. So it's a lot of things going on. We double click to open it and use here to set the parameter input proximity zone, block groups, and proximity zone. Oh god, okay, I didn't name it well. So proximity zone, not proximity zone, and then demographics. So all attributes. So proximity zone demographics. Okay, click OK. Perfect. So now we have everything. The name of the output of identity proximity zone demographics is too long to fit in the oval, so it is being cut off. So the text display on the elements in the model is just labels and can be changed. Although each label defaults to the tool or data it represents, we can change them to enhance the display and readability of the model. We will right-click the output green oval of the identity tool and click rename. So rename, but I don't want to rename. So I think, well, I could rename. So proximity zone demographics, yeah, it's fine. So all right, so better I just rename it. Okay, put a comma, space, not comma, there. So proximity zone demographics. So, and then I'm gonna save it again and move on. So we will validate the model, and once we validate the model, and the only thing we will have to do is continue to build this model. So the issue, this is a good time to run the model before running a model. We should validate to make sure that all is well and with the data, variables, and tool parameters. And on the model builder tab in the run group, and we will click validate. So the validation ensures that a model has access to its source data if we rename. So if we rename, remove or delete a feature class referenced by an input data variable, that variable and its dependent processes will turn gray, not ready, when we validate the model. And similarly, we will delete a field from the table, and that field is specified by a tool parameter. And the tool and its dependent processes will turn gray when we validate. So if nothing run gray, so means our model is ready to run. So which is really nice. Okay, and then we will continue to run our model. What we're gonna do right now is we will do next step is to run the model. So we will do is in the Model Builder tab in the Run group, we will click the Run button. So run here. And as it runs, we should get a visual progress report with each tool running red. It is as processed. As a progress dialog box is displayed, including detailed messages here. So we will close the message box when the model is finished running. So in the model window, the tools and output data elements have a dropped shadows. So dropped shadows is down here. And then we can see that drop shadow. So the shadowing tells you which of the tools are complete. So now that the tools have run and the model is complete, we can view the results and add them to the map. So in the project pane, we will browse to the model outputs geodatabase. So gonna back in our catalog. So model outputs geodatabase. That's weird. Let's see. So everything is in my let's see, buffer, and it's geodatabase. Yeah. Oh, I think the reason is I need to refresh. There. Okay. I forgot to refresh. Sorry. So now the tool have a run and the model is complete. We can view the results and add them to the map. So in the project pane, that browse to the model outputs and geodatabase and refresh the geodatabase by right-clicking it and click refresh. So I forgot to refresh, okay? And the geodatabase contains 4 feature classes. They have the names assigned by the tool parameters in Model Builder. So now we open the Lesson 7 map by clicking the tab, open the model, and get a new one, and we will drag the proximity zone demographics layer to the map. And we will view a little bit. And I think I'm gonna expand maps. Gonna go to a new map. Close this out. So map, and I will rename it. Okay, Lesson 7. Okay, and then I will just say right click on it and add to display. Okay, so open the attribute table of the proximity zone demographics layer, and we will scroll across to see its attributes. So okay, so alright, so the attribute, the table has 206 records and includes the demographic attributes from the block groups feature class. It is the same result that we got already, and configuring the identity tool is the last step in the current model, so we can assume the other layers are correct if the identity output is correct. So now we're going to remove this layer and switch back to the mode by click the tab above the map and save the model, and then we will continue to run. So here we're going to do is that we will keep working on the workflow and finish the model. So now we use attribute and spatial query to narrow down the number of the potential park site. So queries, so that we use the query, any type of feature to or record selection are not made directly on feature classes, but rather on layers. So to make feature selection in Model Builder, we therefore need a special tool that turns in an input feature class into a layer. This tool approximately name is make feature layer. So we make feature layer in Model Builder. It is usually to make a selection that can be used as an input to further processes. So For this tool, we already view a little bit, but we're going to use it and test it so we will understand a lot better, and we will put them all together and see how it goes. So next, we will use an attribute query to select feature in the proximity zone according to the demographic values we assign from block groups using the identity tool. We will recreate that query now. So if necessary, we will start everything here, and then we will right click the model and click add it. But I have my model here. I don't need to click add it. And then we will open the tools list and search for make. I don't think I need to search for it. So, and I will have make a layer, make a feature layer. Yeah, make a feature layer. So then I have this make a feature layer tool is similar to select by attributes, but instead of selecting and highlighting the feature that satisfy an expression, it creates a temporary layer that filters the features. So both tools allow you to define a query to limit the features that are used in subsequent tools. So here we will use the tool to define the demographic criteria to be used in the next step. So we will double click here and to open this tool. So, and then you can see the definition query here. So, approximately demographics and output layer, I will say good zones. Remember our good zones. Good zones. Okay. And then we will add a class. Add a class. Actually, we have to add a lot of classes, remember? So the first, add a class to select features in here, and we will do, the first one is population density. Population density, and is greater than or equal to 800, 8500, and click add, and then add another class, and median house income is less than or equal to 50,000, and click add a class, and under 18% under 18 is greater than or equal to 22, and click add. So we have the three clauses. So population density is greater than or equal to, and median house income is less than or equal to, and percent under 18 is greater than or equal to 22. Perfect. Okay, we make a feature layer also gives you the opportunity to hide unnecessary fields. That we will go ahead and remove the extra fields that were added from the buffer steps. So we will hide all the fields except for the following. So I'm gonna do, oh my god. So invisible object ID. So by clearing except I need this, and I need shape, and I don't need proximity zone, I don't need name, I don't need this, I don't need this, I don't need this, no this, and then we need population density. Yeah, population density. Where is population density? Yeah, population density. Population under 18. Okay. So all I need this, and I don't need square my population density under 18%, under 18. I don't need this. 1, 2, 3. I have a 3, and then shape and object ID. So these fields are the only ones we need for analysis. So and then by hiding, I'm gonna scroll down. So by hiding the others at this point, they will be excluded from feature class in the model, and we can prepare, click OK, and auto layout. So put the auto layout. Oopsie, so I don't want to here make a feature. So why this tool here? Proximity. Click OK. input feature there. I'm gonna delete this one. Yeah. And then fit to auto layout, and then fit to screen. Okay. And the Model tab has several navigation tools in the view and model groups for panning and zooming in and out of the model. We can also use the scroll wheel as well as horizontal and vertical scroll bar to navigate the model. So I'm going to save the model. Okay, we still have to continue. Then we will select puzzles within good zones. So the attribute query for desirable demographics significantly narrows down the good zones in which we can look for vacant puzzles. We now have the model builder equivalent of a layer with a definition expression set, bringing us the point in the analysis where we were at the here. So the next thing to do is to make a spatial query for vacant puzzles that lie within the good zones. So here, for make a feature layer and drag it to the model next to the vacant puzzle element. So I'm gonna right here. Okay, and then we drag a line from the vacant puzzle to make feature layer tool and set it as an input parameter. So input parameter. And here we did a selection by location query for vacant puzzle in the good zone, followed by an attribute query for puzzles a quarter acre or larger. We are going to now switch the order of these two query operations by adding the attribute expression to the make feature layer tool, but it doesn't affect the logic. It doesn't matter whether we first select the vacant puzzles in good zones and then select the quarter acre ones. Or first select all the quarter acre vacant puzzles and then select the ones in good zones. So we will do it now. So we double click here, and then so that I will have change the output layer name suitable size vacant puzzles. Suitable size vacant puzzles. Suitable size vacant puzzles. Okay. And then we will add a clause. So the area, the acreage is greater than or equal to 0.025. And then click OK. Remember, we want everything, I think. Yeah. So we did select by attribute query for a vacant puzzle in good zone, followed by an attribute query for puzzle a quarter acreage or larger. We are going now to switch the order of these two query operations by adding the attribute expression to make feature layer tool, but it doesn't affect the logic. It doesn't matter whether the first select the vacant puzzle in good zones and then select the quarter acre ones. So the first select all the quarter acre vacant puzzles and then select the ones in good zones. So now we will change the output layer name to suitable size vacant puzzles, and we add the cross here. Acre is greater than or equal to 0.05. I think something wrong is here. So greater or equal to 0.05, 0.025. Click add. SQL. Yeah, I'm gonna change here, just 0.25. Validate. Yeah. And it should be good. And then compare to the tool. Search for the select by location tool and drag it to the model and next to the suitable size vacant puzzle. And select by location, select a layer by location, select a layer by location, and suitable size. Okay, put it here, suitable size vacant. Alright, we will open the select layer by location tool and use the figure here to complete the parameters to select vacant puzzle that are completely within the good zone and click OK. Alright, so now I'm gonna see. We're gonna link it. Okay. Select by location. Gonna put input layer, and then I'm gonna double click on it, and I have to change some parameters. So we don't have to do anything more here. So this one will be completely within. Completely contains completely within. And then selecting feature will be good zones. Okay. There, and click okay. So we open the attribute select layer by location tool and use the figure here. So suitable size vacant parcel and completely within, and then good zones and search distance, everything is fine. New selection, and we're gonna click OK. So use the figure to here and completely within, and we will rename the last output element. Click OK. So I'm gonna auto layout first, and then this one, suitable size vacant parcel, good zone parcel layer. So I'm gonna rename. So I'm gonna call it good zone parcel layer. There. So now note that the last output that actually creates a feature class in the geodatabase is proximity zone demographics. We can tell by the shadowing of the last green oval right here. Creates a feature class in the geodatabase proximity zone demographics. We can tell by the shadowing of the last green oval. The subsequent outputs consist of two layers created by the Make Feature Layer tool and selection on those layers. We will hover over the proximity zone demographics elements, so which is this one. The tooltip shows that the path of the dataset on disk, so which is in my geodatabase for the output one. So hover over each of the downstream outputs in term. So these two tips show only the name of the layer because that is all there is to see. No data sets have been created on disk. There are 4 output elements, but only 2 layers. Good zones created. So good zones is created. So and then here we don't see. It's just different. There was something created. Yeah, those you see something created. But here we don't see anything yet. Created by Make Feature Class, Feature Layer, and Suitable Size Vacant Parcels Layer. Created by Make Feature Layer 2, Good Zone Parcel Layer is a spatial selection of vacant parcels. You rename the output elements of the selection tool for clarity, hopefully, but we didn't have to. And then we have to copy feature class. So just here, we will use the copy feature tool to save the selected good zone parcel as a new feature class in the geodatabase. So we will search for copy features. We don't have to search. Everything is just here. I'm just dragging. So copy feature class, we drag it in line with a good zone parcel layer to the copy feature tool and set it as the input parameter. So then I will drag it here, input parameter, and then everything is here. So I'm gonna open this tool, and for output, you can already see model output. So I will just call this layer good zone parcels. There. So that's the output, and we will click OK and auto layout fit. All right, and then we will save the model, the project. And this feature class contains the recommended sites, but we will add a little more information about the sites to be included in the final output. And then we will determine the distance of each site to the river. So we know that each site is within a half mile of the river, but just as previously we did, we will use the near tool to set a precise distance to help the decision makers on the city council weigh their options. So here for the near, I'm gonna go back and do near, dragging here. So near feature parameters to the Los Angeles River. As a reminder, there is no output feature class when using the near tool because it simply adds field to the input feature class. So we will change the method parameter to geodetic. So double click on it and input it will be good zone puzzles and then near feature. So Los Angeles River, and search field that will method. So it will be geodetic. And then there was no output. Okay. But I remember I have to set the river, isn't it not? So let's see. Near the set the near feature parameter to this as a reminder. There were just new when there was new because okay. So I have to go back to the near tool that we did previously. Just give me 1 second. I'm gonna double check. Let's see, near tool. Okay, near. So yeah, it's on page 235. We don't have to set anything. Calculate distance to the river. That we do not have to set here. Okay, the reason was near to. So okay. Know that we can add a multiple layer to the list. Near to the 2 is discover feature 1 closest, and we don't have to set y. Calculate the distance. So because here it doesn't create a feature class, it just measure how far is it from it. So we don't have to search anything. Okay, now I'm gonna do auto fit and auto layout, and then auto fit to here. It's really weird. Look. Okay, I'm gonna drag it a little bit and auto fit window. I do use Los Angeles River, and that's really crazy now. And it really looks weird. Okay. Can you auto fit again? Okay, and then we will determine park access population. That we will have a lot to do. So now I'm gonna move my river. So where's river? So if I remove my river, gonna save, and then I want to select. Okay, I'm gonna move here. Okay, this thing. Okay, so I move this thing all here, and then do auto layout again. Fit to. There. Okay. Move this here. Okay. So now the park access is determined as the population within a quarter mile of the site. We made this calculation using the spatial join tool, that within a distance operator and a merge rule. So here we will search a spatial join. So I don't think I have to search it. Everything we used it before is available for us. Spatial join is right here. So for spatial join, I drag the tool and the model right next to the good zone puzzle with river distance. So, and we will open the tool and set target feature class to good zone puzzle and then within the river distance. So target layer will be good zones. Where are good zones puzzle layer with a river distance. Okay. I don't have a river distance with a river distance. Okay. I need to rename this. So rename. Okay. I forgot to rename this, and the rename good zone puzzles with river distance. there. And and we will set join. So I'm gonna double click this again. So with river systems join feature, and then centroid, block centroids, okay. And then here we will say site to access. Sites access. And this will be the final output of the model. We will delete unnecessary fields from the output attribute table. We will make sure to delete carefully so that the mouse click do not get ahead of us. So in the list of output fields, we will click the first field in the list. It should be excuse me, shape length. To select it, we will click the remove button. So right here, so we remember last time we did a lot. So drawing will be 1-to-1. We only leave acres, so we don't need this. We need acres, and then river distance. Which one is river distance? Okay, I think I changed that. River distance, and then we have the river distance. Yeah, near distance. Okay, not this one. And we need population 2010. Okay, that's the other one. Alright. So if I misdelete something, I have to reset everything here. So hopefully not. Okay. Perfect. So remember that we have to change the name. So the first one we will do is the river distance. So double click here. So merge, it is first. So river distance, we have to see slowly. Okay, so the list of the here river distance, and change the both field name to river distance. So property, yeah, river distance, and then population, river distance, and then population access population, okay. And I'm gonna go back to access population, and access population we will change it into sum. Alright, so let's double check, and within a distance, and the radius, it will be miles, 0 to 5. Okay, we changed the population, and on the property tab, we changed the field name and alias to access population. So which is right here, okay. Access population, and we change it into sun. And with access population still selected in the output fields, we click the source tab and left the property tab, and then click sum in the merge rule drop-down list. Match option defines the spatial relationships to be evaluated. We must evaluate the block centroid within a quarter mile of the sites. We will change match option to within a distance, which I did, and then the search radius to 0.25 miles. We compare the tool and everything. So this set essentially means that the population 2010 values of all the block centroid points within a quarter mile of each site will be summed and included in the output in the population 2010 field. And now we will rename the output elements of the spatial join tool from the sites access to sites with access population. So access population, click OK, and we will save the model, and everything is fine. And we will attach the demographic attributes. So to do that, we have one last step, and then we should be able to run our model and do more. So we still have a lot to do. But it's okay. We will do it. Okay, we attach the demographic. We will have to attach the demographics attributes. So now we're nearly done with the model, but now we will we will overlay the sites with the block groups to get the demographics attributes. We already know that these sites meet the demographics criteria, but adding the individual numbers for each site will help decision makers evaluate the sites at a glance. So in the list of tools, search for identity and drag the tool to the model right next to site with excess population. So I have to rename this, so I forgot. So this will be sites. Sites with excess population. There. And then identify tool is right here. No, I don't need to click. Identify tool, intersect tool, identify tool is right here. So we drag the identify tool here. So and then we will drag to the line from site with excess population to connect to the tool as the input. So no. Okay, input feature. And then drag to draw a line. So then I'm gonna drag to draw a line from the good zone layer to connect to the tool as the identify. Which one? The good zones identify features there. So everything should be fine now. So we drag a line from the good zone layers to connect it to the tool as the identity feature parameter, and then the good zones layer is a great input because it already has all the unnecessary attributes hidden for us. So this will save some cleanup steps. So we will open new identity tool and change the output feature class name to recommended sites. So right here I'm gonna rename recommended sites. And we will compare everything, and we will rename recommended elements at the end of open the identity tool and output feature class name recommended sites and output there. Okay, so now everything is here, and we should be ready to run the model. I think I'll just do a full screen. No, I cannot do a full screen, but just put it here then. Okay, so I'm gonna close everything out. And I can run the model now. So on the model builder tab, and we click run the model, everything is, I think it's done, right? Yeah, it's successfully. And when the model is finished running, close the message box. All the elements should now display with gray drop shadow. Yep, everything is drop shadow. If the model did not, we will have to check. So going to view results, we open so I'm gonna drag it out and then I'm gonna go back to view and then go to, where's the contents? Contents is right here. Yeah, contents, and then I'm gonna uncheck this and then go back to model builder and fit window auto lay and recommended. Okay, so in the project pane we expand the model builder outputs geodatabase and drag recommended site. So I still have to go back to view and to catalog pane. Perfect. All right, so going to refresh our geodatabase, and then if we do not see the output, we refresh the geodatabase by right-clicking it and click refresh. We will open the recommended site attribute table, recommended site attribute table. I don't see it. Recommended site. I'm gonna refresh it again. I'm gonna add to display. Alright. Okay, then I'm gonna open attribute table. Okay, so see, we have the same field. Let's see again. All right, 1, 2, 3, 4, 6, 7. Yeah, yeah, we have the same results. We just have to change the fields view, and we run the model as a tool. So here we're gonna wait until next time to talk about how to run the model as a tool, and then we will still change some parameters, and then we will play around with the model. So this model we will have to come back and to review a little bit. I know it's overwhelming. It's a long time, but it's okay. We finished the procedure. It's like 70 minutes. We putting things all together, and we did it slowly. But when we run the model and then we will set up some parameters. That will be really cool. Okay. So I will see you next time.